I know it says use a string, but I'm just a rebel. I'm determined to make this work. Oh look, it's working. Yeah, every time I hear the name Archimedes, I can't decide whether to think about the owl from Sword in the Stone or some Greek guy running naked down the street because he just popped out of a bathtub. So, we're going to be calculating density using the Archimedes method, which involves some mass calculations. A reading of 1.0 on the scale here. Do some of this off camera and right back. Alright, next we're going to be looking at initial concentration and molarity. And the first thing we're going to do is measure the mass of this lovely little flask here. .1 grams. We're going to measure out 8 grams of sugar. Put this here, we're going to tear the scale, so we've got a reading of 0 again. We've got some sugar here. A little overboard there. Alright, we're looking at 8.0 grams of sugar, allegedly. Carefully transfer sugar from paper into a volumetric flask. Well, this it's going to be challenging. We have a winner. Alright, now we'll be filling this to the 25 milliliter mark, which is that lovely mark you can't see right there. For time purposes, we're going to do a couple steps off camera. Alright, a couple steps later, now we have this lovely solution of sugar water, and we're going to go ahead and start making some calculations for a dilution series here, or at least recording some data. Won't bore you with the calculations. Alright. Yeah, there's going to be a lot of, I'm going to make some solutions. Alright, just to show the steps in making a solution here, I've taken my sugar water from my flask, my sugar solution, from this flask, transferred it to this flask, and now we're going to take, looks like 2.5 milliliters out of here. That's 2 point, let's got it. That's 2.5. And now we'll finish filling that up to 25 milliliters and take the mass. And we'll repeat that a couple of times for solutions of varying strength. Alright, so having prepared a solution that's 6 milliliters of my original solution combined with, presumably, 19 milliliters of distilled water, we're taking the mass, and we'll calculate density and molarity off camera, because gosh, who wants to watch that stuff? Lab 2 coming up next. Alright, in Lab 2 we'll be looking at the differences between chemical changes and physical changes, hopefully. Got a slightly different lab kit here than apparently I should have, so off we go. Alright, so basically what we're doing here is we're taking samples of 7 different substances, which is magnesium, copper, zinc, magnesium oxide, let's see, copper carbonate, copper nitrate, and sodium chloride, which, if I remember right, is table salt, but we're just going to let that go. First, what we'll be doing is making some observations about the material itself. I'm going to start with the magnesium. Remember to wear your safety gear. It's very important. You don't want to be unsafe. Alrighty. So, in the magic of test tube number 1 here, let's get something a little cleaner. Ah, yes, the other end. I love the other end. Not sure how anyone does anything with these lab gloves on. Or, man, these tweezers are not the best. Let's try the plastic ones. I feel like a monkey in a trap right now. Don't worry, I'll edit this part out later. No, I'm just kidding, I won't. Matter of fact, we're just going to do the whole thing in CGI. If I get Danny Elfman to do the music, it's going to be greatness. Alright, so we got some magnesium here, physical properties. It's reflective, metallic, kind of irregular in structure. There's something about it that's a little bit milky. It's not quite shiny like you'd expect a chrome or steel surface to be. And we're going to decide that that's enough of that substance. Alright, let's see if it has anything like odors or whatnot. No, it's odorless. For my purposes, I'm going to call it colorless. Well, you know, metallic, whatever. Alright, so here we have it. There, like that. Alright, we're going to go ahead and apply some heat here. Looking for changes of some sort. Careful not to ignite this stuff because I'm not really equipped for that right now. Hopefully it would burn okay in this test tube. I have no idea. Pretty sure magnesium burns at, like, you know, 800 degrees or something, so, or possibly even higher. And I'm not really observing any kind of change in this substance at this time. Right. And we'll let that cool for a minute. It's like a great place to let it cool. Empty container. It's beautiful. And the second thing we're going to do is test this same substance, magnesium, for cold water solubility. Alright, and how much water should we use? Quarter filled. Alright. Test tube number 2, quarter full of distilled water here. After all, I live in Texas now. I have no idea what's in the water. I don't want to test that. I don't really want to think about it too much. I hear it's there's a local problem with filtration regarding pharmaceuticals and such. All right, before I heat it, I'm gonna shake that around, see if I can. You know, it doesn't appear to be doing anything at all, but kind of floating there. That is not any sort of solution I'm familiar with. I don't observe any changes at all. No change in color. Probably not a change in flavor. I don't know why we're not testing for that. I mean, okay, I kind of know. And we'll just heat this baby up right here. Yeah, we got it to boil, and the only change I see now is the magnesium is now on the bottom of the test tube instead of floating on the meniscus, which was more likely caused by the size of the sample particles than by any sort of buoyancy. Probably. I'm not an expert. Alright, so that is magnesium tube number 2. The third thing we will do with this magnesium sample is add, while the letters say HCl, the tube probably says hydrochloric acid. It's corrosive. Be very, very careful when handling chemicals. you'll end up like Dale from King of the Hill. Whoa. Alright, so there we go. Another sample of magnesium. You know what, I'm going to go ahead and put sample number 4 in here. I suppose I could have done this off camera, but this is so much fun. No, really, it's pretty cool. Alright, so now we're going to add a few drops of hydrochloric acid to this thingy right here. I'm sorry, this sample of magnesium. Hydrochloric acid right here. Alright, we're just going to hold this away from ourselves. 1, 2, 3, 4. Now there's definitely a reaction occurring here. As soon as that hydrochloric acid hit the magnesium, we had some nice fizzy stuff going on. There's definitely a release of gas here. Let's see if I can. Oh yeah, that's an exothermic reaction for sure. A little bit of heat there. Looks like the reaction's kind of died down a bit now. A lot of solids left at the bottom there. No observable change in color. Well, the liquid portion appears to be less clear and more opaque now. There's definitely some kind of whitish looking sediment in the tube. So yeah, I'd say something happened, that's for sure. I guess I'm supposed to stir this, so here we go. Can't see that really made a difference at all. I'll go ahead and put that in a little container of test tubey stuff and take this, rinse it off. Alright, so we have our paper towel, which is partially wet with distilled water, partially dry. Alright, and the fourth and final test we will perform on all 7 of these substances, 6 of them off camera. And it's going to be adding some sodium hydroxide here to this magnesium, so let's go ahead and be safe about it, right? Move this thing way out so we're not doing anything crazy. 1, 2, 3, 4. And we are looking for signs of some kind of reaction. And stir that. I'm not seeing anything visible. Doesn't appear to be any change in temperature. You know, I don't think I want to go around like testing caustic chemicals or possibly caustic chemicals for odors. That just sounds like a recipe for disaster. So we're going to repeat that process for 6 more substances, and we'll be back on camera after that. I keep wanting to say things like stay tuned for a word from our sponsor, but it's not happening. Alright, one of the things we almost did is skip a step. Test tube 2 has the distilled water added to the mystery substance, in this case still magnesium. And one of the things I needed to do with it is take this piece of blue litmus paper here, and this piece of red litmus paper here. Right, posture. Work on that. using the stirring rod device. Place 1 drop. Come here, drop. Wow, they have a frictionless stirring rod. No, just kidding, I got some activity here, just not what I'm looking for. There we go. Yeah, no real change on the litmus paper, and if I remember correctly, one of these measures acids, the other measures base, and water is basically neutral. So what I have is no evidence of reaction that produced a solution anyway. Well, no evidence of a reaction in that tube at all, actually. But yeah, so 6 more substances. We got this.